In this next section, we're asked to use the properties of integrals in order to take integrals we already know the values of and look at different transformations of those integrals. So there's 4 general properties we'll be using. First one says if we don't move at all, if we go just from a to a, then the integral equals 0, because if we haven't moved, we haven't accumulated any area. The second one tells us that if we change the limits and we started going b to a and now we go a to b, we get the same answer, it's just negative. The third one tells us that if we have a constant times some function, we can pull that constant out, find the integral of the function, and just multiply by that constant. The fourth one tells us if we have 2 different functions of x, we can split them into 2 different integrals and keep the same sign, whether it's plus or minus here, as plus or minus here. So we're asked to evaluate using the following 3 values. These are all the real answers. I actually did realize that I uploaded originally this 2 as a 4. I apologize. This really should just become 7 minus 5, which is 2. So I must have made a quick math error when I was doing that. But please, on your papers, change this to a 2. So if I look at a, and I'm trying to compare it to which of these 3 I can use, a is the same as this first integral I was given. The only difference is instead of going 5 to 7 like my example integral, this goes 7 to 5. So I'm really using property 2 that says if I switch the 2 limits on the integral, it gets the same answer, just negative. Before I got 444, the answer to this will be negative 444. For part B, it asks me the integral from 5 to 5 of x dx. This is using the first property. Since it says 5 to 5, I haven't moved at all. That's why I have 0 area accumulated. For part C, I'm using this constant property. I have a 1/4 that I can pull out. So this really becomes 1/4 times the integral from 5 to 7 of x cubed dx. We know from above that 444 is the integral from 5 to 7 of x cubed dx. So this becomes 1/4 times 444, which gives me my final answer of 111. For part D here, I'm asked to do negative 9x dx from 5 to 7. I can pull that negative 9 out as a constant using the third property. So then I'm going 5 to 7 x dx times negative 9. 5 to 7 x dx was given to me as 12. So if I do negative 9 times 12, that'll give me the correct final answer, which is negative 108.